Hello, my name is Ben Dietz-Hilaire, and this is my acceptance test for a Codesys instruction list program with visualization. The purpose of this test is to verify that a start power push button provides master power control, and that two switch inputs are combined through a XOR logic operation to control three lights. The key requirement is that all three lights behave identically because they are driven by the same final logic result. The instruction list executes top to bottom using a working value known as an accumulator. The program loads switch 1 into the accumulator, then performs a XOR operation with switch 2. That XOR output is true only when the switches are different. One is on and the other is off. After the XOR results is computed, the program applies the start push button using an AND operation. This makes the start push button act like a master enabler, or a master enable. If start PB is off, the final accumulator result is forced off no matter what the switches do. Finally, the program stores that final accumulator value to light 1, 2, and 3 in three separate store instructions. Because the same value is stored to all three lights should always turn on and off together. I have my Codesys project open and instruction list program loaded. The visualization window displays three inputs, switch 1 and 2, and the start push button. It also displays the three output indicators of light 1, 2, and 3. I am running the application in simulation or online mode so that input changes in the visualization will update the program logic and the output lights in real time. First, I will verify that the start push button truly acts as a master control or control power. By flipping the switches, you can see that they do change from true to false, but the lights do not activate. Even if the XOR logic becomes true, the AND operation with the start push button should force the final result to stay false. This does confirm that the start PB locks the outputs. I'll now enable the start push button, setting the value to true. And to verify that the XOR behavior or XOR control is behaving properly, I'll set switch 1 to on and all three lights turn on. The same will happen with switch 2. And with both switches set to on and the power button still on, it results in the same as them being switched to off, confirming that the XOR logic is properly working. Throughout every step of this test, I verify that light 1, 2, and 3 are always in the same state. They turn on together and off together because the same final accumulator value is stored to each output. To conclude, the instruction list program passes acceptance testing with the start push button correctly acting as a master control, preventing outputs when off. When on, switch 1 and 2 correctly follow XOR logic. Turning the lights on only when the switches are opposite. And finally, light 1, 2, and 3 match at all times because they are driven from the same final logic result. Thank you.